I'm Bruce Brecky. I'm the bridge maintenance engineer for the Iowa Department of Transportation. We maintain our bridge decks primarily by placing low slump concrete overlays on deteriorated decks. For over 20 years we used a machine called a DeLamtech. This machine sent sound waves into the bridge deck and determined delaminated areas that were hollow. Those machines are approaching the end of their service life, and they are not produced anymore. We're faced with coming up with new technologies to obtain that information. So we're very interested in what Rutgers University is doing, because without new technology we would be back to the old method that was used by many years ago of hand sounding, and it's still used in some cases where the deck is actually mechanically hand sounded by tapping, by drawing a chain over the deck, and the inspector then interprets the sound that he hears and is able to then determine where the delaminated areas are. Obviously that's very time consuming. It depends upon the inspector's interpretation of those sounds. So we're very much interested in the technology that's being tried out here in Iowa.
Today we're working on this bridge deck using a few non-destructive evaluation techniques, primarily ground penetrating radar, impact echo, ultrasonics, and portable seismic property analyzer. We're also using a half-cell measuring device on a rolling wheel, and we were doing some resistivity probe measurements. So we'll continue to do the same measurements that we were doing the last couple of days. Around us you can see the grid where we have measurement locations that show where we're taking a lot of these point measurements. And they also form lines along which we collect our ground penetrating radar, or GPR, measurements. So the ground penetrating radar is the most rapid of these techniques. You can scan 60 scans per foot, or 5 scans every inch, and it scans at a rate of about 390 scans per second. So you can move at a walking clip and pick up a continuous subsurface image of what exists inside the deck. And inside this deck there's concrete that is covering a mesh of transverse and longitudinal rebars that strengthen the inside of the deck. What we're trying to primarily look at is measure the strength of the radar return from every one of the transverse bars that we cross along each line.
The other techniques that we're using that compare to the radar is of course electromagnetic. Some of the other techniques that we use that are also comparable to the electrical properties would be resistivity. We're using a 4-pin Werner method, typical in seismic types of, we use that sometimes in the seismic area or in the field to determine the conductivity of the soil. We're doing the same thing here, and of course the conductivity of the steel rebar changes as it corrodes. We're also using half-cell chloride ion content technology. We are connecting to the steel grid. It becomes like a battery, if you will, and we can measure at each point along the bridge the potential, the electrical potential at that point. The other technologies that we're using actually look for the delaminations, or the cracks that are caused by the corroding steel rebars. The portable seismic property analyzer will give us the modulus of the material, the concrete. The impact echo that is on what's called the stepper. And the stepper has 2 technologies on it, ultrasonics and also impact echo. As the frequency and the returns from the impact echo, then we know that we have some delamination. When we get back to the office and we start analyzing the data, one of the things that we'll report is of certainly accuracy, because we have cores on each of the bridge decks. We take cores and we are comparing those to the responses we get from the other equipment. But when we get back, we'll take that data and analyze it. We'll be looking at the accuracy of the data and also the speed of data collection. And so we want to balance the accuracy of the data and the speed of data collection. And that's what we'll be reporting to Iowa DOT and so they can make the choice of the most effective and efficient technology to use.